In this case, we want the moment around axis AB as a Cartesian vector. So we want the vector form of the moment about an axis. So we want moment as in component form about the AB axis. This is how we can notate it. So it's, again, this is not the same. This is only the magnitude of the moment around the AB axis. This is the vector form, the Cartesian component form of that. So that's where we want to end up, and we'll see how we're going to get there. The diagram, I'm going to basically copy what we were given. So in this case, our origin is located at point A. The pipe goes in the xy plane to a point B, goes vertically to point C. And at point C, we're applying a force, and here it's given to us already in component form. So negative 20I plus 10J plus 15K newtons. We want to know the moment around axis AB, which means we're going to later on need that unit vector. So we want to, and we're going to need to know the moment about a point on that axis. So we're going to need to know, since we have a force acting at C, we're going to need this coordinate also. So I'm going to put the coordinates of B and C on because it's going to help us in later steps. So point B, I have to go 3 in the x direction. I have to go 4 in the y direction and 0 in the z from the origin to get from A to B. And for point C, I have to, if I start at B and then go up by 4, or in the z direction by 4, I'll arrive at point C. So point B is at 340, and point C is at 344 meters. And A is the origin. Questions on the diagram step. Again, really just copied but added the coordinates to help me in finding unit vectors, finding position vectors next. For my equations, I'm actually going to go kind of backwards on this so we can see where do we want to end up so we know what we're going to need to find along the way. Again, I want the moment as a vector about axis AB. So we'll go one step backwards at a time. What will we need to know in order to find this quantity? It's going to be the magnitude around AB times U hat, in this case, AB. How are we going to find U hat AB? The magnitude is going to be the moment about a point on the axis dotted with the direction of the axis. So in this case, we can use point A, we could use point B if we knew any other point, if I added a point here. Because I'm given A, because I'm given B, I would probably use one of them. So what I can do is I can take the moment around, I would probably do it around point A only because it's the origin. It's going to be a little bit less work. So I would probably do the moment around point A, and I dot that with, again, the direction of the axis. But I could use the moment around point B dotted with the axis. So we will use R cross F, which is the R that we want to use to find the moment around point A. Right, so remember, this is going to be the vector that points from the point we want the moment about A to where the force is being applied. In this case, it's being applied at point C. Notice here, for the cross product, to find the moment about the point, I'm using RAC. This is a different vector than what I use up here, and also this is a position vector. Here I'm using a unit vector. This is the unit vector of the axis I want the moment about. But here I have to use the position vector. Specifically, I needed to know, start at the point I want a moment about, to where the force is being applied. So these are not the same, and they rarely will be. RAC we know how to find. F was given to us. So now if we look at the steps we can take if we start down here and kind of go back up, we're going to end with what we're looking for. So we want to identify things that we know how to solve, and then things that are going to be kind of another step in that process. So we can start here by finding the moment around point A due to this force F. So here we use the cross product. F we were given its components, so I'll fill those in. And that's going to be in newtons. Now the middle is RAC. To find that position vector, it'll be the coordinates of C minus the coordinates of A. Again, I chose this one because A is at the origin, so it's just C minus A, which will be 344 meters. Had I chosen the moment around B, I would have had to use RBC. In that case, it would have been C minus B. It's not really more difficult, but it is just one more step because C minus B would be 0, 0, 4K. So we would have a different position vector in that case. Wednesday, we went over, again, how to expand our determinant, so I won't do that step now. We take the cross product of two vectors. We get out a vector when we expand that determinant. So for this, we get that the moment around point A will be 20I minus 125J plus 110K. Newtons times meters. So how do I find this unit vector? Right? It's going to be the position vector AB over its own magnitude. Position vector AB I can find by taking the coordinates of B minus the coordinates of A. Conveniently, A is at the origin. So this is just going to be 3 minus 0I plus 4 minus 0J plus 0 minus 0K. So I'll just leave that out. The magnitude of this is going to be 5. So I get that the direction of this axis is going to be 3/5 I plus 4/5 J. I have unit vector AB. In the previous step down here, I found the moment around point A. So in now my going back up a step, I can go in through this dot product. So this will be 20I minus 125J plus 110K dotted with what I just found here, 3/5 I plus 4/5 J. The dot product is going to take two vectors, combine them, dot them together, and give me a scalar value. So remember, it's a different process than the cross product. For the dot product, what do? I multiply the like coefficients, and I add them together. So in this case, I'll have 20 times 3/5 plus 4/5 times negative 125 plus 110 times 0, which is going to be 0, so I'll leave that one out. So I get 3/5 times 20 minus 4/5 times 125. I will get the magnitude of the moment around axis AB is negative 88 Newton meters. Right, so I have the magnitude of the moment around that axis. I can go up one more level because I now have the moment around AB as a magnitude. So the last step is, if I want my answer in Cartesian component form, I multiply what I just found, the negative 88, times U hat AB. I have a scalar times a vector, so I can just distribute that negative 88 into it. I'll get negative 52.8I minus 70.4J. And the units, since this is a unitless quantity, the magnitude of that moment was in Newton meters. This is also in Newton meters.